Good morning. My name is Alfred from Johnson Controls. I'm a service technician. I have a lot of experience in the installation and service on these fan coil units. This particular one that we're looking at, this is a horizontal ceiling mounted two-pipe system. It only does heating. So if it was dual cooling and heating, it would have been a four-pipe system. Now, so this one is a two-pipe heating only. Later on, we'll go on and show you the other application, which is the duct high static fan coil units and the floor-mounted vertical stand-up ones in the, I think. Well, there's, I don't know how many in total, but there's 3 different types as far as the application.
Why is this unit installed on the ceiling? This is for heating only.
Yes.
It should be on the floor. Why is it ceiling? Because, you know, the hot air is going up.
We sell you guys the units, your engineers say design it.
It's a bad design.
Well, that's not on Johnson Controls, you know. So I'm here to tell you the general operation and maintenance on the equipment as far as the safety procedures and stuff like that. Now, I'm going to read a couple of things, and if you have any questions, we're going to go over it later when we open up the equipment. And so normal operation and periodic maintenance. Each unit on the job will have its own unique operation, environment, and conditions that may dictate the maintenance schedule for that unit that is different from the other equipment on the job. The formal schedule of regular maintenance and an individual unit log should be established and maintained. This will help and achieve the maximum performance and service life of each unit on the job. So the motor assembly, the type of fan operation is determined by the control components and their methods of wiring and may vary from unit to unit. Motors are permanently lubricated, which is PSC, and EC type do not require field lubrication. So they're permanently lubricated, they're not accessible for any form of lubrication. The fan deck, the fan assembly is easily removed from the unit without disconnecting the ductwork, which you will see the high static unit later. The ductwork for service access to the motors and blowers at or away from the unit. Should the assembly require more extensive service, the motor blower assembly may be removed from the unit to facilitate such operations as motor or blower wheel, housing replacement, etc. Dirt and dust should not be allowed to accumulate on the blower, wheel, or housing. This can result in an unbalanced blower wheel condition that can damage the blower wheel or motor. The wheel and the housing may be cleaned periodically using a vacuum cleaner and a brush, taking care not to dislodge the factory balancing weights, which you will see the weights for the balancing. It's located on the blower wheels. So if those get dislodged, then the blower wheel becomes unbalanced and damage the motor permanently. Balancing weight on the blower wheels, which is located on the wheel blades, which we will look at it later. The coil. Coils may be cleaned in place by removing the motor, blower assemblies, and brushing the entering air face between fins and the soft brush parallel to fins. Do not brush perpendicular to the fin operation, as damage may occur. Brushing should be followed by cleaning with a vacuum cleaner. If a compressed air source is available, the coil may also be cleaned by blowing air through the coil fins from the leaving air face. Vacuuming should again follow this. Units provided with the proper type of air filters, replacing regularly, may require periodic coil cleaning. The electrical operation of each unit is determined by the components and wiring of the unit and may vary from unit to unit. Consult with the wiring diagram for the actual type and number of controls provided on each unit. The integrity of all electrical connections should be verified at least twice during the first year of operation. Afterwards, all controls should be inspected regularly for proper operation. Some components may experience erratic operation or failure due to age. Wall thermostats may become clogged with dust and lint and should be periodically inspected and cleaned to provide reliable operation. I'm not sure where the thermostats are looking.
Right outside, well, this side of the building, outside of the
Okay, so you guys just gotta get familiar with where all of these are located. When replacing any components such as fuses, contactors, or relays, use only the exact type, size, and voltage component as furnished from the factory. Any deviation without factory authorization could result in personal injury or damage to the unit and will void the factory warranties. All repair work should be done in such a manner as to maintain equipment in compliance with governing codes and ordinances or testing agency listings. More specific information regarding the use and operating characteristics of the standard controls offered by the manufacturer is contained in other manuals. The valves and the pipings. No formal maintenance is required on the valve package. Components must commonly used with fan coil units other than the usual inspection for possibly leaks and the course of other normal periodic maintenance. In the event that the valve should need replacement, the same precautions taken during the initial installation to protect the valve package from excessive heat should also be used during replacement. If a strainer is ordered with the unit and the strainer must be cleaned periodically along with other scheduled maintenance. In some cases, the valve actuator may fail and usually can be replaced without removing valve body from piping, which just the top of the actuator can need to be replaced if the motor goes. The valve body can remain. There's a clip that would unclip the top of just the valve body and just the top of the actuator, but the body don't have to unsweat it to replace the actuator. Electric resistance heaters typically requires no normal periodic maintenance when the unit air filters are changed properly. Other conditions and equipment may affect the operation and service life of the equipment. The two most important operation conditions for an electric heater are proper airflow and proper supply voltage. High supply voltage or poorly distributed or insufficient airflow over the element will result in element overheating. This condition may result in the heater cycling on the high limit thermal cutout. Open wire type heaters provided have an automatic reset switch with a backup high limit thermal switch. Automatic reset switches are as the name implies. They reset automatically after the heater has cooled down. The high limit thermal cutout device is a manual reset safety device. With the proper unit application and during normal operation, the high limit thermal cutout will not operate. This device only operates when some problems exist. Any conditions that causes high limit cutout must be corrected immediately. Once the high limit trips, it may be reset once the unit has cooled down. Refer to the troubleshooting section manual for the high limit reset instructions. High limit supply voltage also causes excessive amperage draw and may result in tripping the circuit breaker or blowing of a fuse in the incoming power supply. The type of throwaway filters must be commonly used on the fan coil units should be replaced on a regular basis. The time interval between each replacement should be established based on a regular inspection of the filter and should be recorded on a log of each unit. If the replacement filters are not purchased from the factory, the filters should be the same type and size as the furnished from the or recommended by the factory. The drain. The drain should be checked before initial startup and at the beginning of each cooling season to assure that the lines are clear. If it is clogged, steps should be taken to clear the debris so that the condensate will flow easily. Periodic checks of the drain should be made during the cooling season and maintained to free flow. But this particular unit is heat only, so there's no drain condensate to worry about. If there's another one with which is a two-pipe system, which I don't think, these are all heating only in this building. So I don't think the drain is necessary to talk about in with this particular units. So we're going to go ahead and open up the units and see what we got. So the unit is most of the maintenance for the unit is accessible from this panel. There's hinges, so these two screws allow you to pivot the door down. There's another safety feature so that the door don't come slamming down in your face. It's a chain hook which you unhook. And there is the motor. It's quite accessible if you have to replace it. Got a transformer over here. Got the shut off before you do anything. It's the main shut off. Before you go ahead, and that's the blow wheel, which you can use pressurized air to blow off the fids. If it collects dust, that will minimize the airflow. And then this is a washable filter. You slide it down from the channel, you put it back. Quite easily accessible. If you guys have any questions, that's the control valve up there. I'm sorry, there's dust. The valve is located up there. That opens and closes due to the coil for heat from the thermostat. And this is your.
Only one gauge over there. Yeah. Pressure.
How are you going to see it?
Oh yeah, you can see the blue valve. As you can see, this is a 2-pipe system, so it's heating only. Normally, there would have been a cooling coil right behind this one, or right up next to it, if it was a dual pipe situation. I guess they don't require cooling in here. And that's a transformer. If you guys want to go up and take a look. I said that motor up there is ported for the motor to stay cool with the air that's passing over it. It is designed to stay cool with the air that passes from the return over. That's why there's no need for maintenance on the motor itself. It's all sealed. If that motor goes bad, then you just got to replace it. And there's four bolts.
I don't know if you know it or not. Well, this is tied to the BMS?
I heard that there's a thermostat there, so it's probably independent, which I don't really know the engineering design. So my controls department would know more on that. I'm more on the mechanical side. I mean, the other units, they basically going to be look the same way, just different application. This one, it takes in air from this vent, and it puts out air through this one. So that's a return supply about a foot or 14 inches away from each other. You could see it on that one. The other one is going to be ducted, which is high static. And so you're probably only going to see just the return, not the supply. And then the other model will be the vertical stand-up unit. So it's a fan housing, motor, coil, transformer. All the control voltage and high voltage located in this area. Of course, the external field piping comes in, and check for leakage, and there's not a lot of maintenance required. It's a pretty simple
The pressure
setup.
picture over there, what's the pressure supposed to be over there?
Again, that's your balancer. The balancer would know that. You know, they have to balance the amount of GPMs that go through. So I think I saw him walking around. And they didn't really face the gauge where I can see it either. So there really should have been some kind of access door, but
No, they
Like
have
a
the
cell
right.
phone, a telephone.
downstairs I can't really see the pressure gauge.
You take your telephone and make like a selfie over there, and that's it.
Yeah.
What's the
Yeah.
problem?
Because that's what phones are for, right?
Yeah, this is what the cell phone is made for.
And a mirror.
Yeah, the mirror.
Any questions on what you're looking at? So put this one back in action. Switch back on. You said that there's a thermostat over here. And your partner was asking if it's on the BMS. But this is the thermostat. I just saw it lit up. So it says fan coil 18, they're labeled. So I don't think this is on the BMS.
No circuit boards.
It's supply air sensor, but that works along with the thermostat. So they have a supply air sensor right there. You keep that sensor clean so that it reads accurately. I'm sorry, you were asking?
There's no circuit boards on here, right?
Okay, well, we could do it right now. We open up that and we see what's in there. That's your little circuit board right there.
Oh, circuit boards.
There's one of you guys to see for yourself.
Broken already? No. No, all right. There's nothing considerable.
Nothing major.
At least it's only one.
Doing this with gloves is a lot easier. Anything else before I close this one up? So drain right here if you ever have to drain the line for any repairs or replacement on the equipment. The isolation valve.
How to connect hose to this drain?
Which,
No room.
right here. You're gonna have to use real flexible type hose or one with an angular fitting.
Okay.
Who made this unit? Johnson Controls?
Yes. But they make the unit according to what they're told as far as the design and the application. So, thank you. So these units are made a special order according to what the engineer wants. You see, there's no, according to how the ceiling is set up, the accessibility is going to be what it is. They have a light. They have a light here, and they have.
Access door is right there behind you, Alfred.
Right.
In the ceiling, that access door. This thing, right here.
No, he was not talking about the access to the drain lines and stuff like that. So
Okay.
this is not gonna, you know. There's only so much the factory can do. We have this. The electrician didn't really strap those up.
Labels wrong. This is unit 1A. The thermostat is control is 1B.
And the access is a lot better.
Is this one heating only, right?
It is heating only because I see that the drain is not connected. So if the drain is not connected, then there's no condensate.
Gonna rain.
I like these ceiling tiles. Look,
Right.
finally
Do
something
you know-
I like.
Can you remove this one for me?
Which one?
This one.
It's right under the unit.
Or just so they can see.
Under the unit they need to see?
Yeah, because I think that the
There should be
filter,
an access door there.
there should be an access door for the filter there. Sorry, man. Well, the access door is an open.
That's the return.
So the access door, they didn't put an access door because is this connected?
Yeah.
So the access door is missing now. This is no good.
We gotta call Mikey.
That means the air is
Let's see if it's up there.
the air is bypassing the filter.
Dirty right now.
No, the coil is going to be dirty. Well, the filter is clean because the air is bypassing it.
Dirty.
Right. That's no good.
On the wrong side too.
No, I don't see that.
Is this ducted on both sides?
Is there what?
This is the return, right? No. This
really.
this is the return.
Yeah.
This is the return.
That's the return. That's the
That's the supply. So you need an access door put back here.
Okay, well, not me, but Mikey, yes.
So we have to call Mike before this is forgotten about, because if the coil gets dirty, then we.
Mikey, the thing of the doctor's thing.
The freaking filter's already turned.
It's dirty on the wrong side because that thing's open.
It looks like it's missing nothing.
So Guys, this is the filter. Oh, sorry. This is the filter axis. These two clips. This comes down, the filter comes out. There's another clip here that it swings this way, the filter gets entrapped in there. I can't really get to all the way unless this is removed, but there's another clip here, the filter comes down. You don't have to open the whole access door just to replace the filter.
They don't want to have fun. Why is he not here? But he's the one that's going to work on it,
So if this is the return, this return grill would have probably been a lot more dirty if it was pulling through the return.
Okay.
It's bypassing the return. So, and it's also bypassing the filter. That's why the filter is dirty on the opposite side. So far,
how's that coil going to be looking?
so far this is good. So far this is good training because we already found an issue with the installation. And we actually came to the right unit. So now they got to go around and they got to make sure that all the other units have that door on there. As far as how the coil is going to be looking, you'd have to remove the blower assembly to find that out.
Can you see the pressure on it?
So that's a pressure gauge. We can actually see this one, and that's also the actuator.
If it's open, it's saying 100 psi.
Yeah.
100?
That actuator, you can actually replace just the actuator and leave the body. So you don't have to unscrew the whole body to get the actuator off. Any questions on this unit? You could see it's the same exact operation, just a different type of application.
Any question, guys?
Except for the
Hey, for now it's sucked air from the plenum.
no, it's not.
It should be covered here.
Well, that's what we've been going over.
Yeah.
And the cover is needed because without the cover, the filter does nothing.
Right, yeah, I've already notified the contractor.
Okay.
Mikey already knows, so he's going to take care of it.
All right, so just make sure that the rest of the units are checked also.
Okay.
Because it could come back on the factory if the airflow is not good.
That's fine.
And the coil gets the coil gets messed up. So this is the vertical stand-up model. It mostly used in hallways and tight walkways, which is hard to get by. So they make it very sleek, so you can just put it to a corner. And this is heating only again, because you could tell these are the only two pipes going in by the labels: hot water return and supply. Return air enters from the bottom, so there's a filter here, and the supply come off the top. This seems to be on a BMS system because I don't see, maybe that's the thermostat for it, but I'm not sure. Yes, it is. Yes, so that's the thermostat right here. Fan coil unit R2, which is labeled, so.
Yeah, that sounds about right.
got nothing here. You want to start the system? Let's turn the fan on.
Let's put it in the off. Let's put it in the off position.
Off?
So yeah, so we will enter the equipment.
They got 2 of them here.
There is a third one also in the water heater room.
Same thing.
3 on this floor.
So I mean, this one you could see better than the one in the ceiling. You could see the valve better, and a little more accessible than going up on a ladder. Yeah. Any questions on it while it's still open? It's the same information, just different application. So, unless there's something we wanted to go over, we can do it. Again, I'm Alfred from Johnson Controls. I'm here to go over the basic mechanical operation of the VAV's boxes in the ceiling, which is connected to the air handler ductwork. This particular one, you can see is connected to air handler R5 on the supply. These work with the BMS system as far as modulating the airflow. There's a damper inside, and it gets a signal from the BMS system, which actually gets a signal from the air handling unit, which modulates the amount of airflow that goes to each vent, as far as making sure that each space get the appropriate and sufficient airflow. Each of these gets closed off. The VFD drive on the roof either ramps up or slows down according to it senses the static building up, and it will ramp down according to how many VAV boxes are fully open or half open. If all of these boxes close down, the drive gets a signal to slow the fan to the minimum amount of airflow. So these and the drive works together. Now, as far as how it modulates and does its thing, we have a control guy who's going to explain all of that in his training session. So I'm just going to go over the basic maintenance of it. I'll turn this on. So, as for the maintenance, the optional damper actuator, an operational factory-mounted floating type actuator is available, which mounts directly to the damper operating shaft. The actuator is not provided with and does not require any limit switches, but is electrically protected against overload. Manual override, there's a button on the side of the actuator. Cover disengages and the gear train so that the drain shaft can be moved manually. Releasing the button will re-engage the gear train. Mechanical angle of rotation stops. The adjustable stops may be field adjusted to halt the rotation of the damper blade before the damper blade reaches the damper stops. The actuator can be indefinitely installed in any position without arm. Loosen the two end stop screws using Phillips head screwdrivers, being careful not to unscrew the captive nut under the slot. Move the stops to the desired position and retighten the screws. The damper shaft. There is an indicator on the end of the shaft that can be used to determine the position of the damper blade. If the indicator is horizontal, the damper is completely open. So if the indicator is, damper is completely open, the damper shaft is half diameter. The frequency of required, with the coil, the frequency of required cleaning is dependent on the operating hours of the system, filter maintenance, and efficiency, as well as dirt load. As for the checkout instructions, first you disconnect actuator from the controller. Second, apply 24 volts to the common and CW terminal on the actuator. Actuator should be rotated in a clockwise position. Apply 24 volts to the common and the CCW terminal on the actuator. Actuator should rotate in a counterclockwise direction. If the actuator moves in both directions, it is operational. If the actuator does not rotate, it may be at an end stop or there is a problem with the damper. If the actuator does not rotate, loosen the set screw to free the actuator from the damper shaft. Check to make sure the damper shaft rotates freely. Check to make sure that the actuator is not again stopped, and repeat steps 2 and 3. If the actuator does not rotate, replace it. As far as cleaning, disconnect all electrical power to the equipment tag and lock out power source. Gain access to the coil either through ductwork or optional coil access panel. Use soft brush and vacuum to remove loose debris from sides of the coil. Do not use fluid or solvents to clean the coil, as no provisions for collecting liquid exist on this type of equipment. So there's no drain pan, so you can't use liquid to clean the coil because there's no way to drain the system. So you're either going to be brush or pressure, air pressure. If these are equipped with electric heat, the electric heaters come equipped with a primary auto reset limit switch. These limit switches provide protection against overheating. The auto reset limit switches automatically cut the heater off when overheating occurs and turns the heater back on when the elements have cooled down. There's no electric heater in any of them. Okay, well, there will be no need to go over that. So all you have is the water actuators in the whole building. All of them is like this. Okay. So that will be it until the control guy explains further on this particular equipment.
Good to me.
I just wanted to give you a mechanical rundown and maintenance on the system, which I don't see much access here.
That's what I was going to ask you.
But
so this, let me see the flashlight. Is this our access to the coil to clean one side?
Yes, and hopefully the filter.
I don't see.
We will have to get the.
Well, the supply's coming this way, so that's
Yes,
the side you want to
right.
clean
So
anyways.
the filter would be over here,
Yeah.
and that's where you
They
take
have
the
filters
filter.
on this?
They should have filters,
Really?
but again, design, they might not put them up there, but they come equipped with that. Maybe by design they just use the filters from the air handler. But they usually have their own individual filtration.
Don't see nowhere where they are.
It'll only be right there.
It'll be the only place.
I don't see nothing sliding in. It'll be right there.
So this one by design might not have a filter, because it's saying the frequency is required cleaning of the coil is dependent on operating hours of the system. Filter maintenance and efficiency as well as dirt load, but we won't know if there's a filter unless we get in touch with the installers and the engineers who design. They could eliminate the filters, or the filters could still be there. Unfortunately, I'm just from the factory. I don't know what they changed on our equipment to meet, because they could take filters out just to meet CFM, you know, with the balancers. And I don't want to tell you it's up there if it's not. Unfortunately, this ladder is not tall enough for me to get up there, so to take it apart. But next week, you guys have a training with the BMS guy, and he could elaborate further.